Welcome back. Mrs. Saunders here. It's our last lesson in our mini unit on areas, and today we're talking about areas of similar figures. If two polygons are similar, then their areas are proportional to the square of the scale factor between them. What? Sometimes, especially in a situation like this, it's easier to just jump in to an example so I can show you what the heck that says. Here's the example. So it says, let's see, triangle JKL is similar to triangle PQR. That symbol right here is the tilde. That means similar to, which means they're the same shape, but not necessarily the same size. They're kind of like zoomed in versions of one another. So we know that the area of JKL, that's the one on the left here, is 40 square inches. And we want to use that to find the area of PQR. Notice we know the side of one is 10 inches and the side of the one on the right is 12 inches. Now those sides are corresponding sides, and I know that because JK, the first two letters, let's go over here, the first two letters, and PQ, those are also the first two letters. So I can use that information too, for step number one, find the scale factor, which is 10 over 12. But it's always easier to work with fractions if you reduce it. So 10 over 12 reduces to 5 over 6. Now step two says square the scale factor. So I take 5 over 6 and square it. I multiply it by itself. This gets us from a one-dimensional to a two-dimensional measurement. So 5 over 6 squared is 25 over 36. That's my area's scale factor. And now I can set up a proportion to solve. So 25 over 36, that's left over right, equals 40 over x, because I know that the area of this guy on the left is 40, and I'm looking for the area of this guy. And then I can just cross multiply to solve. 20x equals 1440. So remember cross multiplying. 20 times x, 36 times 40. And divide both sides by 25. So the area of my right triangle is 57.6 inches squared. Let's try another one. All right, so we have two triangles that are similar. It says we have a pair of similar figures, so that's good. And what do we have? We've got two side measurements, and we're going to use those two for step one, find the scale factor. 11 over 44 reduces to 1/4, all right? Now we're going to square the scale factor. So 1 over 4 times itself is 1 over 16. So that's now my area's scale factor, and I can set up a proportion. So I've got 11 over 44, and then look at, they gave me the area of this little guy. We need the area of the little guy over the area, we don't know this one, of the big guy. 1 over 16 equals 20 over x. And then of course we just cross multiply. 16 times 20, 1 times x. X is 320 inches squared. Not bad, eh? This time, we got to go backwards because this time, look at what, we're missing the side. We have the two areas, but we don't have one of the sides. So we're just going to use it backwards. So step one, use the areas to find a reduced proportion. So we've got 4590 over 510. Those are horrendously large numbers. If you reduce it, it becomes much prettier. It's just 9 over 1. Now before, we would square the scale factor. This time, if we want to go from the 2 dimensions of area to a 1 dimension of the sides, I'm going to take the square root of the scale factor. So the square root of 9 over 1 is 3 over 1. And go ahead and leave it in a fraction because that's going to make it easier to cross multiply here in just a second. Now we've got our scale factor for the 1 dimensions, the sides, and here's my proportion. 3 over 1 equals 21 over x. And then we'll cross multiply. 3x equals 21. So x equals 7 meters. So that's that, the area of similar figures. Just go ahead and go through each of those steps, and I think it'll be a breeze for you. Thanks for being here.